GCSE double award chemistry full course revision for CCEA. Quantitative chemistry. The relative atomic mass of a substance is the mass number in the periodic table, and the relative formula mass is all the relative atomic masses in a compound added together. A mole is a relative atomic mass of a substance in grams, and 1 ton is equal to 1,000 kilograms, whilst 1 kilogram is equal to 1,000 grams. You convert kilograms to grams by multiplying by 1,000, and to convert tons to grams you multiply by 1,000,000. On the screen now is a formula triangle and how you calculate moles. So mass is on the top, and to find that you times moles and relative atomic mass. And on the screen now is how you calculate moles concentration and volume. Rates of reactions. Concentration. So more particles in a space, so more collisions, and therefore more successful collisions leading to a faster rate. Twice the concentration will lead to twice more collisions, and therefore twice as fast rate of reaction. Talking about temperature, particles will turn heat energy into kinetic energy, and so they are hotter and they'll move faster, involving more successful collisions, which will make the rate of reaction faster. Twice the temperature will lead to twice as many collisions, and therefore twice as fast. Catalysts will reduce the activation energy needed and will offer an alternative route for the reaction. If less activation energy is needed, more successful collisions will happen at a faster rate. Surface area. Smaller particles will increase the rate as there will be more collisions at the surface, and more collisions will mean it will happen faster. So if the particles are twice as small, there will be twice as many collisions, and the rate of reaction will be twice as fast. The equation to calculate the rate is mass of reactant used divided by time. The extraction of iron ore in a blast furnace. Right now it's a diagram of the iron ore blast furnace. Stage 1, you'll add your carbon-rich coke. Limestone will also be added to remove the impurities, and iron ore will also be added. This is your hematite. Stage 2 will involve hot air being blown in, so the carbon in the coke can form carbon dioxide, which will then further react to form carbon monoxide. 2CO is carbon monoxide, and it reduces iron ore. So C plus oxygen gives you CO2, and the CO2 plus your carbon will then give you carbon monoxide 2CO. Stage 3, the molten iron will then collect at the bottom of the blast furnace and the reduction of iron ore. So free CO plus Fe2O3 will give you iron plus carbon dioxide. And then in stage 4, your limestones will react with your impurities to form slag, which will float on top of the iron and will be drained off. CaCO3 will give you CaO plus CO2, and CaO plus SiO2 gives you CaCiO3, and this is your slag. In stage 5, the reactions in the furnace produce CO2, and this will rise up the furnace and will be removed. Reactions with metals and oxygen. Potassium will burn with a lilac flame of oxygen, while sodium will burn with a bright yellow flame. Calcium, however, will burn with a brick red flame, and magnesium will burn with a bright white flame and will leave white ash. Zinc will leave a yellow solid, but when it's cold it will be white. Aluminium, when using a powder, will give you sparks and will leave a white solid, whilst iron fillings give you sparks and leaves a black solid. And then if you use copper sheets, this will then leave a black copper oxide. Reactions with water. So a metal plus water will give you a metal hydroxide plus hydrogen. Reactions with steam. A metal plus steam, which is water H2O, will give you a metal oxide plus hydrogen. Magnesium will react violently with steam. It will give you a white powder and will burn with a bright white glow. Magnesium plus steam will then give you magnesium oxide plus hydrogen. Zinc is yellow whenever it's hot and white when it's cold, and zinc plus steam will give you zinc oxide plus hydrogen. And iron will react slowly, and it will also be reversible, and you have to heat it constantly, and that'll be iron plus steam gives you iron oxide plus hydrogen. Reactions with hydrochloric acid. Potassium and sodium react explosively, as potassium reacts with 2HCl to give you potassium chloride plus hydrogen, and sodium will react with hydrochloric acid to form sodium chloride plus hydrogen. Calcium, however, only reacts violently, and calcium plus hydrochloric acid gives calcium chloride plus hydrogen. Magnesium gives a rapid reaction, and it's 2Mg plus 2HCl gives you 2MgACl plus hydrogen. And then zinc will react very slowly along with iron, and basically they'll just equivalent give you zinc chloride plus hydrogen and iron chloride plus hydrogen. Hard water and soft water. Soft water will readily form lather with soap, and it will form temporary hard water when boiled. It will form from permanent hard water by baking soda. Hard water reacts with soap to form scum, and loads of soap will be needed to form a lather. The cause of this is when acid rain passes through rocks containing Mg plus and Ca plus ions. The advantages of hard water is that it tastes better and it is needed for brewing beer. Also, it is good for your bones and teeth and helps prevent heart disease. The disadvantages, however, is that it wastes soap, it's unsightly, and it can block hot pipes with limescale. Temporary hard water can be removed by boiling, and examples are calcium hydrogen carbonate and magnesium hydrogen carbonate, and the formulas, for example, calcium hydrogen carbonate is Ca open bracket HCO3 2. Permanent hard water cannot be removed by boiling, and examples are calcium sulfate CaSO4, magnesium sulfate MgSO4, and only Mg2 plus and Ca2 plus ions can form hard water. The formation of acid rain is equal to water plus carbon dioxide gives you carbonic acid H2CO3, and the formation of hard water is water plus calcium carbonate CaCO3 gives you Ca brackets HCO3 2, and acid rain plus limescale will equal hard water as calcium carbonate CaCO3 plus H2CO3 gives you Ca brackets HCO3 2. When removing temporary hard water, thermal decomposition can be used as Ca brackets HCO3 2 will firmly decompose to give you calcium carbonate, carbon dioxide and water. To remove hard water by baking soda, you would use sodium carbonate plus CaHCO3 2 to give you calcium carbonate and 2NaHCO3. To remove hard water by the ion exchange resin water that is made up of Na plus ion beads, and water passes through with Mg2 plus and will switch places with Na plus ions, and the beads need to be replaced periodically. This is an example and a diagram of the ion exchange resin. Energetics. So exothermic reactions are when as a reaction that gives off heat energy, and examples can be combustion, and this is whenever stored chemical energy in methane is released in combustion. So CH4 plus oxygen will give you carbon dioxide, water and heat energy. Another example is neutralization, which is hydrochloric acid plus sodium hydroxide will give you then sodium chloride and water. A displacement reaction, so zinc will displace copper and copper sulfate to give you copper plus zinc sulfate, and then hydration, this is copper sulfate plus water will then give you copper sulfate and water combined. And when you add water, it'll turn from white to blue. Rusting is the final example of an exothermic reaction, and it is iron plus oxygen and water will then give you Fe2O3 plus water. An endothermic reaction, however, is a reaction that takes heat in during a reaction, and examples are thermal decomposition, so CuCO3 will just give you copper oxide plus carbon dioxide, and this transition is green to black. And the thermal decomposition of limestone is calcium carbonate will give you calcium oxide plus carbon dioxide, and the uses of calcium oxide are paint, plastic and nappies. Explaining why a reaction is exothermic is a common 5 marker that comes up on the CA paper. So I might give you a question: CH4 plus 2O2 will give you carbon dioxide plus water, and the answer, a perfect answer would be the bonds in methane and oxygen are broken. Energy is taken in to do this, making this endothermic, but producing the bonds carbon dioxide and water releases energy, meaning this is exothermic, and more energy is given out than taken in, therefore the reaction must be exothermic. Organic chemistry. So fossil fuels are formed from tiny animals and plants that live in the tropical seas, and a fossil fuel plus oxygen will give you carbon dioxide and water. Fossil fuels are non-renewable and took millions of years to form. Fractional distillation is when heated crude oil is added to a column, and at the bottom where it is the hottest, the long chain molecules with a high boiling point will condense here. Further up the column it is cooler and shorter chain molecules will condense here. In the homologous series, this is a family of organic molecules with some general formula that shows some similar chemical properties. These are the alkanes, notice ANE, There's a structural formula which you will probably be required to answer in your question, and there's methane, ethane and propane. Notice the ANE and their formulas written below them. So methane CH4, ethane C2H6 and propane C3H8. The properties of alkanes is that they have a low melting and boiling point, they have CC single bonds, and they're saturated, so they're strong and unreactive. Alkenes now, however, notice that it's ENE this time. It's a hydrocarbon molecule containing a CC double bond. Ethane and propane make polyethane and polypropane, and the uses of ethane is that it ripens plants and produces vinyl and chloride. Propane's use is that it produces acrylic acid. This is now a diagram of ethane and propane and their structural formula. Polymers are described as a large chain molecule with small bits added together called monomers, and polymerization is the process of adding monomers to form a polymer. Polymerization of ethane is currently shown on the screen, and this could be a question you'd be asked to draw. The polymerization of vinyl chloride is also on the screen, and it is once again a question you could be asked. Fermentation is when yeast converts sugar to ethanol and carbon dioxide, and the hydration of ethane to ethanol is C2H4 plus water gives you C2H5OH, and this is ethanol. The uses of ethanol is that it's a fuel, it's an alcohol, and it's a solvent. Ethanol as a fuel, it burns with a colourless flame forming CO2, water and heat. Alcohols. So alcohol, you have methanol and ethanol. They're the only ones you need to know on the screen right now in the table, and you will need to know their full structural formula and the molecular formula. So methanol is CH3OH and ethanol is C2H5OH. The last group in the homologous series are carbolic acid. Sorry, I'm not the best at saying that. And the first one you need to know is ethanoic acid, and you'll need to know again the formula and the structural formula, and its formula is CH3COOH. The second one you need to know is methanoic acid, and its formula is CH2O2, and that structural formula there. And all of these have a double OH bond, which you will need to know. Ethanoic acid, so CH3CO2H, and then you put your reversible symbol in, will then give you hydrogen plus CH3CO2, and then carbolic acid and sodium carbonate. So 2CH3COOH plus Na2CO3 will give you 2CH3COONA plus H2O plus CO2. Ethanoic acid will react with sodium hydroxide, and its equation is CH3COOH plus NaOH to give you CH3COOH Na plus water. Ethanoic acid and magnesium then will react to give you 2CH3COOH plus magnesium gives you bracket CH3COO2Mg plus hydrogen. So to identify the homologous series, you want to do 4 tests. The first test is you add bromine water to each test tube. There will be 4, and whichever one turns from orange to colourless is hexene. Notice the ENE. The second test is that you will add sodium carbonate to the other 3, and whichever one produces CO2 as ethanoic acid. This will turn the lime water milky. Test 3 is you add orange potassium dichromate and add dilute sulfuric acid, and after heating in a water bath, whichever turns from orange to green is hexane. Notice the ANE. And by the elimination process, therefore, you must conclude that the final test tube contains alcohol. This could be a 6-mark question. Non-metals and non-metal compounds. So hydrogen. To prepare hydrogen, it's H2SO4 plus zinc gives you zinc SO4 plus hydrogen. That's only an example. Hydrogen is a reducing agent, as hydrogen plus oxygen will give you water, and because oxygen has gained hydrogen, it has been reduced. So hydrogen plus copper oxide will give you copper plus water, and hydrogen doesn't produce toxic waste when burned, and so it is considered as a clean gas. When we talk about the greenhouse effect, we know that CO2 and other gases trap heat in the Earth's atmosphere, warming the Earth and melting the ice caps. Polar ice caps melt, and this is caused by a rise in sea levels, and therefore flooding can occur, and a change in weather patterns also lead to habitats being destroyed and plants and animals possibly becoming extinct. A man called Wegener found the theory of continental drift, and this is whenever convection currents allow the plates to move on the Earth. To support the theory, the geology of adjacent continents matches, resulting in similar and identical fossils found around the world. Oxygen. Oxygen is a colourless, odourless and slightly soluble gas in water. The test for this is that it relights a glowing splint. 2HO2 gives you water plus oxygen, and the observations of this reaction is that bubbles of colourless gas is evolved and black solid remains, and this reaction is exothermic. All reactions is that hydrogen plus oxygen will give you water, and this is a clean and redox reaction. And then carbon plus oxygen will give you carbon dioxide, and then carbon dioxide plus water will then give you carbonic acid, H2CO3. Sulfur plus oxygen will then give you sulfur oxide, and this is a yellow solid which will melt to a brown liquid and burn with a blue flame. So copper plus oxygen will then give you copper oxide, and this is black. Zinc plus oxygen will give you zinc oxide, and this is white, but it will turn yellow. Sulfur, this is a yellow solid, but it burns with a blue flame to form sulfur dioxide gas, and that's iron plus sulfur gives you iron sulfate. So sulfur dioxide is a gas that is yellow, it's pungent, it's heavier than air, it's soluble in water, and it forms an acidic solution. And sulfuric acid is formed from SO2 plus water gives you H2SO3. So acid rain effects. In a forest, it will be difficult for plants to produce glucose by photosynthesis. An unhealthy planter will be susceptible to disease, and this could result in complete deforestation. In rivers, fish will die as the water is acidic, and acidic water absorbs poisonous metal ions to kill the fish, and in reflected limestone, it will corrode limestone buildings. Measures taken to prevent acid rain is that burning less fossil fuels. This will mean the production of less electricity, but we can produce the electricity using wind and solar power. Equations is that H2SO4 plus zinc can give you zinc sulfate plus hydrogen, and then hydrogen sulfate plus zinc oxide will give you ZnSO4 plus water, and then H2SO4 plus 2NaOH, that's sodium hydroxide, will give you sodium sulfate plus water, and then hydrogen sulfate plus calcium carbonate will give you calcium sulfate, water, and carbon dioxide. And then finally, and so H2SO4 will give you plus 2NaHCO3 will give you NaSO4 plus water plus carbon dioxide, and finally H2SO4 plus ammonia 2NH3 will give you brackets NH4 2SO4. So carbon, the incomplete combustion of carbon is 2C plus oxygen gives you 2CO carbon monoxide. The preparation is calcium carbonate plus hydrochloric acid gives you calcium chloride plus water plus carbon dioxide. Calcium carbonate disappears, fizzing will occur, and the temperature will rise. Carbon dioxide and water, so carbon dioxide plus water will give you carbonic gases H2CO3. The test for carbon dioxide is that Ca open brackets OH, which is hydroxide, and then 2 at the end, plus carbon dioxide will give you calcium carbonate plus water, and it will turn the lime water milky. The reaction with burning magnesium will be magnesium plus carbon dioxide will give you magnesium oxide plus carbon, and then carbon dioxide and sodium hydroxide reaction will be 2NaOH, sodium hydroxide plus carbon dioxide will give you sodium carbonate Na2CO3 plus water. So nitrogen. Nitrogen is a colourless and odourless gas, and 78% of the Earth's atmosphere is made up from it. Ammonia is a compound of hydrogen in the form NH3, and it is a colourless gas and is extremely soluble in water. The test is that it reacts with hydrochloric acid to form white fumes known as ammonium chloride, and NH3 plus hydrochloric acid gives you NH4Cl. 2NH3 plus H2SO4 will give you brackets NH4 which is ammonium sulfate, and then NH3 plus HNO3 will give you NH4NO3, which is ammonium nitrate. Ammonia can be used as artificial fertilizers, and the Haber process is whenever it takes nitrogen from the air and changes it so plants can use it. So the Haber process is whenever a catalyst is used, and it will be iron. The temperature is usually about 450 degrees Celsius. The pressure is about 200 atmospheres, and then nitrogen plus hydrogen N2 plus 3H2. The wee reversible sign will give you ammonia 2NH3. So the Earth's atmosphere is made up of carbon dioxide due to intense volcanic activity at the very start, and high levels of CO2 made up the atmosphere as it was very hot. And the Earth cooled then, forming the oceans, and carbon dioxide dissolved in water, and it was taken in for photosynthesis by plants. Limestone quarries. So the advantages of limestone quarries is that the selling of limestone improves the economy, and the provision of jobs also improves the economy. New roads will also be built for transportation. The disadvantages, however, is that machinery is noisy, the quarry is unsightly, traffic congestion can be a problem, and fumes and pollution will be given off. Finally, oil is a hydrocarbon, and components are separated in fractional distillation, which we talked about earlier on. Carbon dioxide is produced in its combustion, and an increase in CO2 levels will lead to more global warming. A spillage can occur when transporting, resulting in water pollution, killing aquatic life. The cost of cleaning is high, and the length of time to break it down is also high. To clean the spillages, use a special detergent or specialized bacteria to break it down into harmless products.